G'day everyone, and welcome to the channel. Today, we're diving headfirst into the fascinating world of large language models, or LLMs for short. They power everything from chatbots to those super smart assistants you talk to on your phone. By the end of this video, you'll be able to impress your friends with your newfound knowledge. Imagine this. You're reading a movie script, but the last part of the AI character's line is ripped off. They take a chunk of text and try to predict what comes next, word by word. It's like they've read every book, every article, every Reddit thread ever written. The key is, they learn patterns in language just like we do, and the more data they're fed, the better they get at predicting what comes next. Ever wonder how chatbots can hold a conversation? It's all thanks to LLMs working their magic behind the scenes. The LLM receives your question and starts predicting the next word, then the next, until bam, a complete sentence appears. They actually generate new text on the fly, based on everything they've learned from their massive training data. It's like having a conversation with a really well-read friend who can talk about anything. Except this friend can respond in milliseconds and never judges your grammar. Now you might think LLMs are just mindless machines, churning out predictable responses. But here's where things get really interesting. They don't just pick the most obvious next word, they consider all the possibilities. Sometimes the LLM throws a curveball and lands on a less likely word, just to spice things up. This is what gives their writing that natural, human-like feel. It's like they're adding a touch of unpredictability, a dash of creative flair to keep things interesting. Okay, I know what you're thinking. Hold on, Chris, you just said LLMs are deterministic. But here's the catch. They use this thing called random sampling. It's like rolling a die to decide which word to choose next, even if the probabilities are weighted. This randomness is what makes LLMs so dynamic. It means that even if you feed them the same prompt twice, you're likely to get two slightly different responses. And that's what makes interacting with them so engaging. Now let's talk about training these language behemoths. To get really good at predicting the next word, LLMs need a lot of data. Take GPT-3 for example. This LLM was trained on a dataset so massive, it would take a person over 2,600 years to read it all non-stop. This massive amount of data is what allows LLMs to develop such a nuanced understanding of language. It's like they've absorbed the collective knowledge of humanity, all in the pursuit of predicting the next word. So, how do LLMs actually process all this information? Well, they rely on billions, even trillions of parameters. These parameters are like the settings on a giant soundboard, each one influencing how the model interprets and generates language. The more parameters an LLM has, the more complex and nuanced its understanding of language becomes. With hundreds of billions of parameters, these models are capable of some truly remarkable feats. It's like they've unlocked the secrets of language itself, and they're just getting started. Training an LLM is no walk in the park. It's more like a rigorous boot camp for artificial intelligence. It all starts by feeding the model massive amounts of text data. Then we give it a prompt and ask it to predict the next word. This process, called backpropagation, is repeated trillions of times, with the model constantly learning and improving. It's like a digital sculptor, chipping away at a block of marble until a masterpiece emerges. The amazing thing about LLMs is that after enough training, they develop this incredible ability to generalize. That means they can take what they've learned from one piece of text and apply it to another, even if they've never seen it before. This generalization ability is what makes LLMs so versatile. They can write different kinds of creative content, translate languages, and answer your questions in an informative way. It's like they've cracked the code of human communication, and they're using their powers for good. Now, let's talk about the sheer scale of computation involved in training these language models. We're talking about operations that would take a human over 100 million years to perform at their fastest speed. To put it into perspective, if you were to try to train an LLM on your laptop, it would probably take longer than the age of the universe. That's why we rely on these massive data centers, packed with specialized hardware designed specifically for this kind of heavy lifting. It's like building a spaceship to travel to the stars. Except instead of exploring the cosmos, we're exploring the vast universe of language. Now, pre-training on massive datasets is just the first step. To make LLMs truly useful and safe, we need to fine-tune them with human feedback. During fine-tuning, we show the LLM examples of desired behavior and gently nudge it towards producing similar outputs. This is where things get really exciting, because it allows us to guide the development of these powerful tools in a way that aligns with our values. It's like taking a blacksmith's hammer and turning it into a surgeon's scalpel. Human feedback is crucial for shaping the behavior of LLMs. We do this by providing feedback on the model's outputs, reinforcing the good and discouraging the bad. This constant feedback loop helps the LLM learn what's acceptable and what's not, making it a more responsible and trustworthy language tool. It's like teaching it the Asgardian code of honor, but instead of wielding a mighty hammer, it wields the power of language. It's like being a mentor to a super intelligent student, guiding them towards their full potential. Alright, let's take a peek under the hood and see what makes these LLMs tick. To handle the massive amounts of data and computation involved, we need some serious hardware. That's where GPUs come in. These specialized chips are like the engines of a rocket ship, providing the raw power needed to propel LLMs to new heights. We also need clever architectures like transformers to efficiently process all that information. They use attention mechanisms to assign weights to different words in a sentence, emphasizing those that are most important for understanding the context. Now, LLMs don't actually understand words like we do. They need a way to represent language mathematically. That's where word embeddings come in. Think of it like this. Each word is assigned a unique numerical code, like a secret agent identity. These codes, called vectors, capture the meaning of words and their relationships to other words. This allows LLMs to perform mathematical operations on words like finding synonyms, antonyms, and even analogies. One of the key innovations behind transformers is the concept of attention. It's like giving the LLM a superpower, allowing it to focus on the most relevant parts of a sentence when predicting the next word. They use attention mechanisms to assign weights to different words in a sentence, emphasizing those that are most important for understanding the context. This allows LLMs to capture long-range dependencies between words, making them much better at understanding the nuances of human language. It's like they've developed a photographic memory for language, able to recall the most important details even from long and complex sentences. Here's the really fascinating part. Even though we design the framework for LLMs, their specific behavior emerges from the massive scale and complexity of their training data. We provide the soil, the sunlight, and the water, but the tree's unique shape and character emerge from its own internal processes. Similarly, we provide LLMs with the data and the algorithms, but their ability to generate creative text formats, translate languages, and answer your questions in an informative way emerges from the trillions of calculations they perform during training. It's both exhilarating and humbling to witness the emergence of such complex behavior from these digital creations. It's like we've unlocked a new form of intelligence, one that has the potential to revolutionize the way we interact with the world around us. So there you have it, folks. A crash course on large language models. These digital titans are changing the way we write, communicate, and even think. One thing's for sure, the future of language is here, and it's more exciting than ever. Thanks for joining me on this journey, and I'll see you in the next one.